midterms are very close now. They will be on the next week, inshallah. So during this virtual class, I'm going to go through the chapters we have. As I told you, all the chapters we had are included in the midterm, starting from Chapter 1, Network Fundamentals, Chapter 2, Network Standards and Models, Chapter 3, Network Protocols, Chapter 4, Network Architectures, then Network Topologies, and the last chapter is Network Media and Devices, which we had this week in the face-to-face lecture. Okay, so as you can see, this course is kind of a simple course. It gives the basic knowledge in networking. So as the textbook name, networking or basics of networking. So let's start by networking fundamental, which is our first chapters. So many of the earliest network designers and developers came from the mainframe background. Actually, there's a question from Mr. Adil about can I remove some of the parts, exclude some of the parts in the midterm exam. Actually, I can't do this, Adil, because it's the course should be coordinated in many locations, many branches. You are not the only students for this subject. So actually all the branches should go together with a unified exam. So we can't remove any parts of the material. Okay, even the college itself cannot remove parts, because this is came according to a plan actually by the presidency of the university, not from the college itself. So these are the main points actually in each chapter. That in the first chapter we had the networking fundamentals, in which we have a story about the network and what is a network. So they came from the mainframe background, and in these days there was a big mainframe device in which is connected with many terminals together, and the mainframe acts as a server in our days now. So everything was done through the mainframes. So then BC network grew out of the need for information sharing. Networks can be used to share printers, share data, share applications. So you can share storage. Many hard disks can form a logical hard disk together, and also application can be shared. Any device capable of communicating on the network is also referred generically as a node. So in general, we would refer to the device connecting to the network as a node, without giving specific type to which part does it belong to. There are also low-level protocols that they control the physical process of data communication. They are high-level protocols, and they operate on the software level. So generally, the high-level protocols will be included from the level of the operating system and above until the application. Okay, there are low-level protocols which are, you can find them working in the at the level of the NIC and also around it by the telecommunication processors. Also, they are considered low-level devices, or low-level protocols can work in them. We have defined the LAN, which is a network that connects a computer and other network devices, so that devices can communicate with each other to share resources. So Regarding a LAN is a network of computers together. They have the same network address. Okay, so this is like the physical definition of a LAN. If we have a network and we want to look into how many LANs we have, we just look at how many networks or groups of computers inside this network that have the same network address. So because of that, a LAN typically would be on a small area. So that's the name. That's why the name LAN, local area network, and it connects actually computers together in the same place. There is also the MAN. MAN is made up of many LANs. It's called Metropolitan Area Network, and this division is based on the size. We divide here by the size. So MAN actually spans a city or a metropolitan area. Metropolitan area, we mean like the region of Riyadh, for example. The region of Riyadh is considered a metropolitan area because it has a capital, and which is Riyadh, and other smaller city inside it. And now we also came to the concept of pervasive networking, which means that the kind of communication in networks become everywhere. In other words, many devices now can be part of the network, such as the mobile devices, such as smaller devices than mobile device can be part of a network. This criteria, we call it pervasive networking. And also now the trends in network is the integration of video, voice, audio, and data, which is called convergence. Convergence يعني تقارب. Okay, so these are the main points of chapter 1. We go to chapter 2, which is about the network standards and models. And I would say that for the exam, for your preparation of the exam, you should go into each of the sections. Okay, you should go into each of the sections inside chapter. Don't just read some of the parts and leave the other parts. Know exactly what each chapter has inside it. Know exactly what are the learning objectives, because the learning objectives are the information that expected that after you read the chapter or the material, that what you should learn. Okay, so this chapter discusses the standards and models, specifically the layers. In general, in TCP, IP, OSI, these are considered as reference models for the network. So standards are necessary to make sure that device and application from different vendors can work together. Without these standards now, a Dell computer, for example, cannot be in a network with an IBM computer, cannot be in a network with an Android mobile device. So what all of these have in common? They have the common protocol, the common protocol stack, which is the many protocols that work together to give the standard for the communication. So the standards can be either formal or de facto. Okay, what do we mean by that? That there is the standard, such as the OSI, is considered as a formal. It's the only formal one. Okay. However, TCP/IP is not formal. It's de facto because it is widely used. It is widely used, but the formal, we mean that the protocol is agreed by many standard organizations, and everyone actually agrees to work with it. Can you give me some standard organization? For example, if you remember, we had like IEEE, for example, this is ISO. So these are kind of the standard organization that they are generally involved in the production. ITL also. So they are, everyone cannot deny or argue that anything coming from ISO or these standard organizations that cannot work. Okay. However, TCP/IP is not a standard. Is not a standard for Abdullah. It's okay. No problem. No problem. So this is the main idea in this chapter. For the OSI model, it's the model most commonly used to describe network hardware and software. And we have seen the 7 layers of the OSI model. It has the layers in which the data should go through these layers until it reaches the destination. The equivalent to OSI is the TCP/IP model, which has only 4 layers. Actually, this textbook describes it having 4 layers, so stick to that, because you can see other textbooks, they describe it in 5 layers actually. But for our knowledge here, just stick that with the knowledge that TCP/IP has only 4 layers, while the internet model has 5 layers. So in this chapter, actually, what's required to know the differences between OSI, TCP/IP, and the internet model. Okay, these are 3 models. We should know what are the layers inside. There are 4 in TCP. What are they? There are 5 in internet model. What are these 5 layers? And the OSI also has 7 layers. So now the internet model is currently the dominant model in hardware and software. The primary difference between the TCP/IP and the internet model is that the internet model includes the physical layer defined in the OSI model. So the TCP/IP does not include this. Actually, the function is included in the upper layer. No mention specifically of the physical layer in the TCP/IP. So the other chapter was about network protocols, and in this chapter there is difference between this and the last one. This one illustrates and gives information about the protocols inside each of the layers. A layer is different than a protocol. Okay, a layer is like a domain in which these protocols operate. So we say the IP protocol operates at the internet layer of the okay. So we can say, for example, the FTP operates at the application layer. So the layer is like a logical grouping of related protocols together. Okay. So this chapter discusses this protocol. Protocols are components that allow computers to communicate and can be understood through the OSI model, which each layer of the model represented by one or more protocols. Here also you should know the standards given by IEEE. We have many protocols numbered as 802, 802.11, 802.12. You should know actually the purpose of each of these protocol, what is intended for. So the 802 standard includes the methods for various type of data communication, such for example, Muhammad says 802.11 is the wireless. Okay, and it has versions. Also, you should know the difference between the versions. 11A, 11G, 11N. Okay, there are differences among them. So the TCP/IP suite was developed for the use on the internet, and the AppleTalk protocol suite was developed for the Apple Macintosh network. So in general, this chapter gives you what is a protocol is, and then it goes through the 802 protocols. There are many protocols on this kind of standard. You should know all of them, what are the differences, and then also you should know what are the protocols inside AppleTalk protocol suite. Okay, so when we talk about a suite or a stack, they're the related protocols that work together in order to have the final result of end-to-end communication. Because end-to-end communication needs two parties, of course, and some kind of conversion of data at each of the layers. And then we move to the network architectures. In this chapter, we talked about architectures, and architectures are also logical grouping of the network. It's not like the topology. And topology actually is physical. And also inside the topology, we have the logical and physical topology inside the topology itself. Okay, but regarding the architecture, it gives you how the computers are organized in the network. In another word, how they would communicate. Okay, what is the either they can be grouped into client-server networks, and they are in general more secure than peer-to-peer network. Here in this chapter, we should know and compare between client-server networks, directory service networks, and peer-to-peer networks, and in addition to the hybrid architectures. Okay, so these are all kind of networks: client-server, peer-to-peer, directory-server, hybrid architecture. So we should compare between them, know which one is better in which situation. Okay, because there is no one that is best of all. We can have one of them as a very famous one, widely used, but no one is best than the other. Each one has its advantage. For example, the peer-to-peer is very good, is efficient than the client server when you have a small network, less than 5 or less than 8 nodes inside. Okay, but when you have big network, then you should consider other options: client servers, directory service. So in general, client server network, they can use more than one server dedicated to a single service, like web or printing server, application server. The kind of directory services architecture is the highest in the security, because it has actually a separate server that would manage the security and authentication of users. So managing a directory service network requires a specialized skill set when it comes to the proficiency of the workers. Then the peer-to-peer does not require any specialized people. Then it comes to the client server, it requires some knowledge of the network administration stuff. But the directory service requires a highly skilled person. All resources with the directory server network are viewed and centrally managed as objects. And the user must be able to access directory service management server in order to log in or access any resources with the computer or with the computer network. There are also the hybrid architectures. They're combinations of two or more of the standard networks. Each architecture model has its advantage and disadvantage. This is what you should study and you should remember. Okay. Each architectural type has also advantage and disadvantage. So this chapter is about the architectures. Should know the architectures. Should compare between them. In in form of many criteria. Also, there is something common in all of the chapters that you should also know the terms. Okay, you should know the terms of the terminologies. I mean that you come across. Okay, don't just pass by the strange words or terminologies. You should know about them, at least the definition of each one. Yeah, I will share with you. Actually, this this summary is also available to you, but I can share it with you also later on. So the next chapter is about typologies, and it was the topic of the last week. So in typologies, we talked about different typologies: bus, ring, star, and mesh. Each one, they are they actually are used in the wired topology. So we can divide into wired and wireless. And in the wired category, we have the bus, ring, star, and mesh. What is common is that you should know the shape of each one and the advantage and disadvantage. And I will tell you that the advantage and disadvantage will come directly as a result from the shape. Okay, so the shape of the bus. Now you know that because the shape of the bus, it will use the minimum media size of media, or it does not require a lot of cabling. This will be a feature in the bus. Why? Because it's simple. You can see that and this is not like the star or the mesh, because they have many connections. Means that they have many wires. So each one has advantage, disadvantage, and you should go through the advantage, disadvantage, know how to compare between them. Also in this chapter, there is a section about the wireless topologies. So the wireless networks, they also have topologies. A physical star actually can be a logical bus or a ring. And also hybrid topology use elements of more than one basic topology in a single network. So there is also in the topologies, there is a difference between the logical topology and the physical topology. These are physical topologies, but for the logical topologies, you have only bus and ring. Okay, so the physical star can be logically bus, because here in bus or ring, we are talking about the logic. When we talk about it logically, we mean how the data goes. So if the data goes in a circular way, it becomes a ring, okay, logical ring. If the data goes in one direction, it becomes the bus, logical bus. There are hybrid topologies which use more than one topology together. So wired and wireless devices can be used together in wired or wireless hybrid. And the chapter of this week was about network media and devices. So we talked about many media, which means the cables. Media means the cables actually, and also the wireless and devices that are involved in the communication. So there is a question, but I couldn't get it. You mean inside hub can be logical? Yeah. Actually, if you go through the materials, we talked about two types of organization, which is called the logical topology. Okay. So the logical topology is different, in which you can have a star, physical star, then you can have it to become a bus-based bus in which the data will go from one direction to other, or in a circular way. If you configure it to be in a circular way, then it will be the ring. Okay, otherwise it will be the bus. So in the last that the hub is logical. No. We can't say the hub is logical because a hub is a device, and it's actually one of the devices in the network. Okay, so you use it to construct some kind of network to connect together devices. So in the last chapter, our talk was about, as I said, many media, such as the coaxial paper, cable, and the STB, and UTB, which is shield twisted pair and shielded twisted pair. And you know, all of the three, they use the copper, it's a kind of metal, to communicate the devices. And also they will use then the electricity. Because they use the electricity, they are subject to the interference between each other, such as the electric. There is a question. Yes, I have internet. Yeah, that's right, Muhammad. Yes, that's true. TCP/IP for layers. And so there are some, we should compare between them and know the differences. Actually, we should know that the fiber optic does not have it does not get affected by the interference, electromagnetic interference, which is EMI, and also the crosstalk, which is when you have wires together. This is a feature in the fiber optic, which is not available in all of the others, coaxial, STB, UTB. The UTB is also susceptible to EMI because it's unshielded, but while the STB is shielded, it will be better in this regard. So there are differences. We should know the advantage, disadvantage, and the differences between them all. Then we have for Khalid. Okay, you can go, no problem. So there are communication devices such as NICs, the network interface cards, and they are now usually included in each computer. They are embedded inside. Okay. So we have also hubs, switch, and the multi-access station units. So they all are used as devices inside the network. And we should know the differences between a hub, switch, and repeater. A repeater can be used, as I said, to amplify the signal, so the network can be extended. If the network is, the communication is within 500 meters, for example, you can extend it with a repeater to become 2,000, 3,000 meters with the same quality. We have devices like bridge, routers, and B routers, and gateways. So these all are devices that would connect the networks together. But the difference is that they operate on different layers of the network. Okay, so we should know each type of these devices, which layer usually it does work on, and what is the purpose of it usually. Okay, so That's all for the midterm revision. I hope you start as soon as possible revising the materials and get ready for the exam. Okay, do you have any question? Okay, I will. راح أحسن إن شاء الله. Yeah, we are finished now, so if you don't have questions, you can leave. Okay? So do you have any questions? Okay, then thank you and see you inshallah next week.
Recording stopped.